Earth's magnetic field. Now we know that Earth behaves like a magnet. It's a huge magnet, like so. How we can say that Earth behaves like a magnet? If we have a magnetic needle and we suspend it horizontally, it shows north and south direction. If we rotate it, then it will stay in the particular direction, that is north-south direction. It shows that there is some magnet inside the earth, due to which it is showing the direction which is north-south direction. Second is, if we have a iron rod and we dip in the earth for many times, then it also get magnetized. So it is only possible when there is a magnetic property of earth. Now third thing, the neutral point. Neutral point are those points where the field due to the magnet is equal to horizontal component BH of the earth. They are equal and opposite, then there will be the neutral point. In neutral point, there will be no magnetic field there. So if we take, this is a magnet, the north pole, south pole, this is the direction of north. So here we draw the magnetic lines of force considering the south pole towards the north. In that case, the lines of force from the north to south will be like this. Here also, it starts from north and it starts and like this. Now, the earth magnetic field will be have a direction of earth lines will be always from south to north. This is the due to the earth magnetic. So these are parallel. These lines are parallel lines, so they cannot neutralize it. So the neutralization is possible on the axis of the magnet. So at this point here, point P, and here this point P, there will be a neutral point, means there is no effect of the magnet at that point. So at the neutral point, the magnetic field due to the magnet will be equal to the magnetic field, the horizontal component of magnetic field at that point. So the presence of neutral point shows that there is a magnetic field of earth. Similarly, if we put the magnet north poles towards the north, now it is north pole pointing towards the geometrical north, then we can draw the magnetic lines of force. Here what we say, the magnetic line due to earth will be there, so they will be in the same direction on the axis. So the neutral point cannot be on the axis. Neutral point will be on the equatorial plane, means at the center point. And we see here the direction of these lines are opposite to the direction of magnetic field due to the earth. Magnetic field due to south to north, and they are opposite. So the possibility of neutral point will be on the equatorial field, and at this point and this point, there is a magnetic field due to the earth will be equal to the magnetic field due to the magnet. So these are neutral. So the presence of neutral point shows that there is a magnetic field due to the earth which opposes the magnetic field due to this magnet. So if we have a magnet, then near the magnetic field will be more. And as we go away from the magnet, the magnetic field will be decreasing, but the earth magnetic field will be same. So the neutral presence of the neutral point here and here, it shows that there is a magnetic field due to the earth. Now, what is the cause of earth magnet? How to explain that there is a earth magnet? So first theory जो है वो is given that they suppose that there is a huge magnet, bar magnet, which is well inside the earth, and it is in the same direction of the axis of the rotation of the earth. And so there is a magnetic property of the earth. But this theory is not correct. It is a fail because the inside the earth the temperature is very high. The metals are in molten state. So, and in that condition, the magnetic properties cannot be sustained. If you are having a magnet, bar magnet, and if you heat it, then it will lose its magnetic property. If you hammer it many times, then also the magnet lost the magnetic property. So at the very high temperature, it is not possible to have a bar magnet in this. So this theory failed. Then next theory comes that the motion of molten iron and nickel. Now we know that iron and nickel are the constituent of the earth, and at the high temperature, the iron and nickel, they are in the liquid state. As earth rotates, the atoms of nickel and the iron also rotate. Now at the high temperature, the atoms get ionized, so there will be ions and electrons, and the electrons and charge will move. And we know that when the charge or electron moves, then it constitutes a current, and due to current there is a magnetic field. So this is the one of the theory that the earth has nickel and iron in the molten state, and due to the rotation at the high temperature, there is a presence of the ions of the metals and electrons, and due to this rotation, there is a rotation of the charges and constitute a current, and we will get a magnetic field. This theory was given. Now, one more theory is given that our earth is there, and around there is an atmosphere, and the cosmic rays are coming from the sun. So, due to the cosmic rays or radiation, the atmosphere, there is the ionosphere where the gases are ionized, and due to the rotation of earth, they also form a current, and due to that current, there is a magnetic field. There is no definite theory about the presence of earth magnetic field, which can be partially explained by both these methods, and first method is discarded. So this is our earth, and this is the axis about which earth is rotating in the counterclockwise. Earth rotates from west to east, so it's counterclockwise. The earth is rotating like this, and we have considered that this is the geometrical north and this is the geometrical south. And here there is a magnet, and the presence of magnet can be shown by the magnetic lines of force. If we have the magnetic needle and we draw the magnetic lines of force, then it is observed that the magnetic fields lines start from here and ends here. Similarly here and ends here. It means here there is a north pole of the earth magnet. Here it is the south pole of the earth. Although this side is the axis and we draw it, and this axis is known as the magnetic axis. The direction of this magnetic axis is 11.3 degree in the left side of the rotational axis. This angle is 11.3 degree, and this point is known as geometrical north, and it is known as the magnetic north because it is near to the north of the geometrical north. Here also it is your geometrical south, and so it is known as magnetic south pole. So these poles, but the presence of magnet, or if we consider the earth as a magnet, then here there is a south pole of the magnet towards the north and north pole towards the side. So the rotational axis, actually the rotational axis of the earth is inclined by 23.5 degree, which I have not shown. So actually earth is here, and this angle is 23.5. So this is the rotational axis of the earth. For the simplicity, I have shown like this. Now, the magnetic axis. Magnetic axis is the axis which is passing through north and south of the magnet, and magnetic axis is inclined by 11.3 degree with the rotational axis. The magnetic pole of the earth. Now, the north magnetic pole. Now, the situation of north magnetic pole is at the latitude 79.74 degree, and longitude is equal to 71.8 degree, and it is in the north of Canada. Now the magnetic south pole of the magnet, which here this magnet is at the longitude of 79.78 degree, and the longitude is 108.3 degree east, and this presence is at Antarctica, which is in the south pole. This is in the north pole, this is at the south pole. So actually I have shown that the magnetic pole, south pole, is towards the north magnetic pole, and north pole is towards the south magnetic pole, because the magnetic lines of force, if we draw it, they start from north and end at the south. So the presence of northern hemisphere, the south pole of the earth magnet, and north pole of the earth magnet is in the southern hemisphere. Now we will do some definition. Now what is the geographical axis? Now what is the geographical axis, or this is also known as the rotational axis? Geographical axis means it is the line joining the north geographic pole to south geographic pole. So if a line which is joining the north geographic pole and south geographic pole, then this axis is known as the geographical axis, or this is same as the rotational axis about which the earth rotates. Now second is geographical meridian. Geographical meridian is if we draw a circle, or we have a plane which is passing perpendicular to the geometrical axis, then that will be your geographical meridian. Now magnetic axis. Magnetic axis is the line which is joining the north pole of the earth magnet and south pole of the earth magnet, and this line will be the magnetic axis of the earth. Magnetic meridian. Magnetic meridian is the, if we have a plane which is perpendicular to the magnetic axis, and that will be your magnetic meridian. Now what is the earth equator? Earth equator will be the plane, it is the larger plane which, or circle plane which is perpendicular to the geometrical axis and passing through the center. This will be a magnetic equator. Sorry, this will be the earth equator plane, and similarly magnetic equator, this plane will be perpendicular to the magnetic axis. So we have a 4 definitions, 6 definitions. One is geometrical axis. Geometrical axis is axis which is passing through the geometrical north and geometrical south. Magnetic axis is the axis which is passing through the south pole and north pole of the earth magnet. Magnetic meridian is a plane which is passing through the magnetic axis and perpendicular to the axis. Now geometrical meridian will be the plane, perpendicular plane which is passing through the geometrical axis. Now what is the angle of declination? The angle of declination, if we draw, suppose this is your geometrical meridian, this is your geometrical meridian, and this is your magnetic meridian. Means this direction is north, geographical north and south. This is the towards this, and here this is the magnetic north and magnetic south, and this plane will be the magnetic meridian, and plane which is behind it, that is the geometrical meridian. So the angle between geometrical meridian and the angle between magnetic meridian is called angle of declination. Angle of declination, once I repeat it, angle of declination is angle between geometrical meridian and magnetic meridian. This angle is not constant, it varies from place to place. Now this definition is very important from examination point of view. This angle of dip, this is also very important from examination point of view. Angle of dip or angle of inclination is also known as angle of inclination. Now if we put the magnetic needle and suspend it, so it can rotate in the vertical plane, and if it is the magnetic field is in the vertical plane, and this is the direction, so this direction will show the direction of magnetic field. Now here in the upper direction we have a magnetic field and we suspend it here, so it can only oscillate on the horizontal plane. So when it is here, then this will be parallel to the magnetic axis, so this will be the magnetic plane. So this angle will be equal to angle of declination. Here when we suspend it, and it can, suppose here this is the magnetic needle, this is the north pole, this is south, and if it can rotate like this, in this condition it can rotate like this, so it will be only stable from north and south direction only. So this is the north direction, this is south direction, so it will be like here. But if we rotate like this, then it will give you the total direction of this direction will be direction of magnetic field. This direction will be direction of magnetic field. Now this angle with the horizontal, this is the horizontal plane. So angle with the horizontal plane of the earth and the direction of magnetic field is known as angle of dip or angle of inclination. Angle of dip also varies from place to place. It is 0 at the equator and it is maximum at the pole. At the pole this angle is 90 and at equator this angle is 0. So we can define it. The angle of dip is an angle between total magnetic field and the horizontal earth surface, and that angle will be equal to, now this angle is denoted by delta. So this will be the horizontal component and this will be the vertical component. We can write the component of B in horizontal, then this will be equal to BH will be equal to B cos delta, and BV vertical component will be equal to BV is equal to B sin theta delta. So the magnetic field, which is the total magnetic field of the earth, whose direction is this, then it will have a two component. One is the horizontal component, another is the vertical component. Horizontal component will be equal to B cos delta and vertical component is B sin delta. Now as I told you that if we suspend the magnetic needle in such that it can rotate in the vertical place, then this direction will be, so the direction of magnetic will be, this angle with the horizontal is known as delta, which is angle of dip. Then here the component of magnetic field will be equal to BH and here it will be equal to BB. So BH is the horizontal component, BH will be equal to B cos delta and vertical component will be equal to B sin delta. So total magnetic field will be sum of the magnetic field, vector sum of B horizontal B plus, and angle between BH and BB is equal to 90. So if we divide it, BB bata BH, then B sin delta bata B cos, B will cancel and it will delta. So tan delta will be equal to BB bata H, or we can say delta is equal to tan inverse BB bata BH. So we can find the angle of dip with the help of this method. Now what will be the total magnetic field? Now we know that B is equal to BH plus, so the magnitude of B will be equal to, the magnitude of B will be equal to under root BH square plus BY square. Direction is given by this. Direction is delta and total B will be given by this. So as I told you earlier, then the angle of dip changes with the place to place. Angle of dip is 0 at the equator and angle of dip is maximum at the pole. Now suppose this is the earth and we build the needle here. The needle will be in the vertical position. This is south pole, this is north pole. Here it will be north and south. So the angle of dip will be equal to 90. And if we put it here, it will be, needle will be like here. So it will be, delta will be equal to 0. Okay.